Okay, in this video we're going to take a look at a real-world application of z-scores and the probability distribution curve. So in this question we are talking about manufacturing. It's quite a frequently asked question, and it's saying that they're manufacturing aluminium rods. One of its machines can be set to produce rods of a specified length. The lengths of these rods are normally distributed. That means we can use the log tables to work with the probabilities, with the mean equal to the specified length and a standard deviation equal to 0.2. So highlighting the key points here in the question, normal distribution is important to us. This equal to the specified lengths for the mean, that's going to be important. And of course, the standard deviation. Working with that, then we know that the mean, which was a specified length, we know that in this case it's 40 millimeters. And we're being asked, what is the probability that a randomly selected rod would be less than 39.7 millimeters in length? Well, to be able to find this out, we first have to work out our z-score, because the z-score is the key to being able to look up the table. So we must find a z-score. So start by writing out our formula for the z-score, which you can get in your log tables. So we write z is equal to x minus the mean all over the standard deviation. Now these are all values that we have and we've been given in the question, so writing them out and filling in the values that we know, we have our x is our variable, which in this case is 39.7, and our mean, which is going to be 40, and finally our sigma, our standard deviation, is 0.2. So we can fill those out into the formula now, once we've identified what each one means. We've got 39.7 minus 40 all over our standard deviation then, which is 0.2. And popping that into the calculator then, we are going to get minus 1.5. So we write that down for ourselves then, minus 1.5. Now, that minus 1.5 might cause a bit of trouble to start out with, because when we go to the log tables, we're not given any negative z-score values. When we go to the log tables, we'll find only that they have positive z-scores. So how are we going to work with this? So first, make sure you're on the right page, that you've got your normal distribution, because there are quite a few distributions in the log table, so take a look that it's normal. And then once you've decided that you've got the right one, you're going to scroll down through the tables, or in your case, flick through your book, find 1.5. Now we won't be able to find minus 1.5, so we're going to settle for 1.5 for now. So we locate it, and we're going to take our probability here, and they're telling us it's 0.9332. So if I had a z-score of 1.5, there would be a probability that I'd select a value below that as 0.9332. Now, again, we didn't want the positive version, we wanted the negative version. So we're going to need to draw a sketch to try and figure this one out. So remember, it's normally distributed. That means that the mode, the highest point on the curve, and the mean are the same, which is 40. So we put 40 right down the middle. Then we're going to have our minus 1.5, which is going to be to the left of that 40. So we're looking for that region below minus 1.5. So we're 1.5 standard deviations away on the negative side, so to the left of the mean. Now remember, we couldn't figure this one out. We couldn't get minus 1.5. You will, in some scenarios, be able to get z-score tables and normal distribution probabilities with this information in it, but we don't, and you won't have it for the exam. So it's really important that you know how to work with it when you do get a minus Z score. So what we could find is the positive. So I'm going to draw that in for myself. And it is symmetric, so do try and make your sketch as accurate as you can. It does not have to be perfect, but as symmetric as you can, because that's important for the next step here. So we've got our 1.5, and what we know is that below the 1.5, the probability that a value exists below that 1.5 is 0.9332. That's this purple region that I'm colouring in here. That's the probability that I select a value below a z-score of 1.5. So all of that region is giving us a probability that we've something below the 1.5 z-score, but we didn't want that. We weren't interested in 1.5, we wanted minus 1.5. So how are we going to do that? So if that is the region below 1.5, to get the region below minus 1.5, we're going to use the fact that the graph is symmetric. And what I know is that if I want to find below minus 1.5, which is down here in this yellow region, if I want to work that out, I know it's actually the same as above 1.5 on the positive side. So this is where drawing it symmetrically or as symmetrically as you can will help you to think about it. Those two yellow regions actually represent the exact same area, and that is because it is symmetric. So we're using that fact that the graph is a mirror image of each other, or of itself, about the mean. So the two yellow regions are the same. So how do I work that out? How am I going to find out what that region is worth in terms of probabilities? Well, the whole thing is going to be a value of 1. So that whole curve represents an area of 1, or a probability of 100%. And I know that the purple region is 0.9332. So how am I going to work out the yellow? Well, you have the whole part, which I'm going to highlight here. The whole thing is red, and it's 1. And we know the purple region is 0.9332. So we're going to set that up. 1 minus 0.9332. And that then gives us the leftover piece, which is the yellow, which when we do that works out to be, in our calculators, 0.0668. So 0.0668, which is the yellow region, which is the same as saying 1.5 and above, or minus 1.5 and below. So take a look at that. Make sure you understand the symmetry and that you know why we had to use the positive. Okay, so in this next part, I've done the workings and I'm going to talk you through the thought process that went into them, but it's very similar to what we just did, only this time it's not a word problem. They're giving us just straightforward, here's the mean, here's the standard deviation. Can you tell me the probability that x, some number that we pick out, that it lies between 14 and 26, if you know this information, that the mean is 20, the standard deviation is 5. So whenever they're talking about probability and you're given the mean and standard deviation, you need to immediately think, I need to find a z-score. You have to be able to think, right, z-score. Why do we need a z-score? Well, that's going to allow us to access the probabilities here. So we need to be able to find out what is the z value, because if I can find out the z-score, how many standard deviations away our value is from the mean, then this here, all of these numbers represent from that z-score back to 0. So what probability exists in that region? So looking at the workings that we have, the z-score. This question is broken up into 3 parts. It's broken up into the probability that you get an x that's greater than or equal to 14. So that's this piece inside here. Probability that x is greater than or equal to 14. The next part is that x is less than or equal to 26. So less than or equal to 26, that's this part in here. So I'm going to get those individually, and that should be something that's quite straightforward. So step 1 always is calculate your z-score. I fill in my values. My 14 is my x, minus my mu, which is the mean, which is 20, divided by 5. 14 minus 20 is minus 6. Divided by 5 gives you minus 1.2. Then what I do is I go to the log tables and I look for minus 1.2. And if you take a look, you will not find minus 1.2 in your log tables. So what we do is we use positive 1.2. And if we take positive 1.2 from our log tables, we get 0.8849. And that represents the region from here down, that purple region that I've coloured in. That's what that 0.8849 represents. It's the probability that it exists from 1.20 down. But that wasn't the question. We were looking for minus 1.2 as our z-score. So minus 1.2, what do I do with that? Well, remember, go to where minus 1.2 was and mark it out. But remember, they weren't asking for what is the probability that it's below it. They were asking for the probability that it was above it. So that's why I've drawn in this region as opposed to the region below it. So I've coloured in this section, not the region going down. And why did I do that? It was because it was the probability that x was greater than or equal to 14. So that's why I've coloured in this one. Now, what we know because of symmetry is that these two regions are identical. From 1.2 to 0 is the same as minus 1.2 to 100. That's the same. And it's the same because those graphs are symmetric. When I do that then, I get 0.8849 because it's the same as what we read off in our probability tables in the log tables. So I would write out my answer. The probability that x is greater than or equal to 14 is 0.8849. That's one part of the question done. The second part, we're going to run through the exact same thing. The probability that x is greater than, less than or equal to 26 in this case. So I fill in 26 minus 20 divided by 5. 26 minus 20 is 6, divided by 5 is 1.2. Our z-score is 1.2. So we go to the log tables, we go to 1.2, there it is, 0.8849. So this time we do want that region, the purple region from 1.2 down, because it is x is less than. So it is going to exist within this part of the curve from here down. So our probability is just as we found it. We don't need to do anything or change anything about it. There's the two parts of the question done. But the whole part, the final piece and the final part of the question is find the probability that x exists between 14 and 26. So that's going to need a sketch. That's going to need us to think about what's going on. So I'm going to draw my bell curve as accurately as I can. It doesn't have to be perfect, but it has to give you good symmetry enough so that you can talk about what's going on. There's my mean, and then I'm dealing with minus 1.2 standard deviations below, and I'm dealing with 1.2 standard deviations above. And I'm interested in the region in between. I'm interested in this pink region. What I have and what I have found out is the probability that I am above minus 1.2. So this region in here. And the probability I am below 1.2. So this region down here. I know those two things. But I want the pink. I want the region in between. And if we look at the in between, and we really think about what's going on in the in between, it is the whole graph, right? The whole thing, the whole bell curve, which is 1. And I want to eliminate two regions. I want to not talk about this region and I want to not talk about this region. So could I work out those? So if we look at the blue here, we think there was the yellow graph and it was to the left of that. So I go back up to my yellow graph. Could I work out this? Could I work out what this is? And think about it. We've done it in the last question. The whole curve is 1. The yellow region is 0.8849. So yes, that region is going to be 1, the whole curve, which is 1, minus 0.8849. And if we do that, we'll get 0.1151. So I do know that region. So I go back and I'm going to label it 0.1151. So I'm going to take out that one, 0.1151. I also want to take out the green. If we really think about what that green is, well, it's going to be the purple down. Take that away from the whole thing. So let's go back up. The purple down, take that away from the whole thing. Should give me this. And again, the whole curve is 1. This is 0.8849. So we get 0.1151 again. And why did I need that? Well, I knew that the whole curve minus the blue and minus the green would leave us just with this region here. And if I do that in my calculator, I'm going to get 0.7698 or 76.98%. That's what that pink region represents here. And if you think about it, and think about your empirical rule, if we were 1 standard deviation away on either side, we would have 68%. We've actually gone 0.2 standard deviations outside of that. So it should be bigger than 68, but it should be no bigger than 95. So we know we're in the right ballpark with our answer.